Okay, these are just your objectives, so no need to write these down. Okay, this is just what we're going to do in this section. For units of measurement, let's see, quantity is a vocabulary word, so you're good there. Know that measurements represent quantities, all right? Okay, so you're good as long as you have the definition for quantity. SI is also a vocabulary word, so you should be good there. 7 base units. Just 1 second for this visual. Okay, this is just showing you the visuals for some common SI units. So for length, the most common thing we use is meter, all right? For volume, we use centimeters cubed a lot, and we use milliliter a lot in here. Now liters, of course, is definitely a common volume for a common unit for volume, but we generally use centimeters cubed or milliliters, okay? For mass, we use grams a lot, grams or kilograms. Those are our two main ones. You'll see milligrams and the other ones some in our conversions though. And for temperature, it's Celsius. We use Kelvin though, in all of our gas law stuffs too. So we will use Kelvin quite often. Again, these are just the SI base units. So for length, mass, time, temperature. Okay, weight is a vocabulary word, so you're good. But what's important for you to understand on this slide is that mass does not depend on gravity. So your mass on the moon would be the same as your mass on the Earth, okay? Even though you're lighter on the moon because the acceleration due to gravity is less on the moon, okay? Your weight, however, would be different on the moon than it was the Earth because weight is a measure of the gravitational pull, whereas mass is not. So it's very important that you understand the difference in those two and maybe even expect a question to that on a quiz that you can compare and contrast weight and mass and how they are alike and how they're different. Okay. These are not vocabulary words, so you probably want to jot these down, okay? The SI standard for length is meter, and then kilometer is a version of it. We will do some converting later. And then centimeter is another prefix, but their base unit for all of those is meter, and that's the SI standard for length. Okay, derived units is a vocab, and that's really all you need on this slide. Volume is also a vocabulary word, so you're good. Only thing I may jot down here is volume and then some common units for volume. That would definitely be helpful to have. So liter, milliliter, centimeter cubed, no common units for volume.
Volume is defined as the amount of space occupied by an object. The volume of a solid, like this cube, may be measured in cubic meters or cubic centimeters. The volume of a liquid is often measured in liters or milliliters. 1 milliliter is equal to 1 cubic centimeter. The volumes of irregularly shaped solids can be measured by the amount of liquid they display. For example, this rock's volume can be measured by dropping it into the graduated cylinder and reading the new liquid level. The volume of a gas can be measured by measuring the volume of the container it is in, because a gas will expand to fill its container.
Okay, from that, it is very important that you take away that 1 milliliter is equal to 1 cubic centimeter. Okay, you need to know that 1 milliliter is equal to 1 cubic centimeter, or 1 cm cubed. Okay. The other thing you need to take away from that is make sure that you can find the volume of an irregularly shaped object like they did with the graduated cylinder. You will have to do that in a lab. So make sure that you can find the volume of something with a graduated cylinder by seeing how much water it displaces. All right, density is also a vocabulary word, so you should have that. But again, I would write down the formula for density. I would write that down. I would also write down some common units. So G over cm cubed or G over m are both very, very common that we use all the time. So you might want to jot down some common units as well. So just to reiterate,
The density of a substance is equal to the mass of the substance divided by its volume.
okay, we are now going to do some sample problems. The first sample problem that I do in the video is based off of this one. Okay, so if you want to pause it and write this down, this is the problem from the work that I'm going to do on the next slide. So you definitely want to write these sample problems in your notes so you have something to look at.
Okay, here are your sample problems for density. This first one is the one in your notes you just seen. So if you copy that down, these are the variables for that problem. I would like for you to write your problems this way, where you list the variables and then list what they are, okay? From your problem, 8.4 grams was the mass. I know that because of grams, that tells me that, all right? 3.1 centimeters cubed was my volume. Again, I know that because of the centimeters cubed. The units will tell you what the variable is. I'm just going to put a question mark by density because I don't know what the density is. All right. After you list your variables this way, you're going to use the density formula in order to solve. So you just need to plug those in. All right. I'm just going to rewrite the D because I don't know what my density is. All right. And for M, I'm going to plug in my mass, 8.4. I don't usually carry my units over to do my algebra. I know what they are over here. And then for V, I'm going to plug in 3.1 because that's my V. D is already by itself, so you don't have to do any algebra on this problem to get your variable by itself. It's already on the side of the equal sign. So all I have to do is the math function, which is y. So 8.4 divided by 3.1. Okay. Now we're still it's just sig big. So I've got 2 significants here, 1, 2. I've got 2 here, 1, 2. So my answer needs 2. So 1, 2, 0 doesn't multiply 7 up. 2.7. My units are grams over volume, just like here, mass over volume. And you just take whatever unit being used over here, make the density unit. So for that, okay, so that's example problem number 1. This next one is missing mass. Okay, I have one of each. This one's missing density, mass, and the next one is volume. All right, this one's missing mass. So same process. Here are my variables. I'm going to plug them in to the formula. This time I know these. I'm going to put it in. I don't know my mass, so I'm just going to put it in there so that I don't know what it is. And then for volume, I'll plug in what I have here. 7. Now this one needs a little bit of algebra. Okay, because n is not by itself, and you need it to be alone to solve the problem. You can just use the multiply method, multiply across. If you want this to go with 1, what makes more sense, remember they come up and across, so the 1 just goes to m, that leaves m by itself on that side of the equation, okay? So 1 has m. Over here, you got 37. You can see this. Okay, you got 37 times 207. All right. I'm going to write that here, but as I write it, you know you need to do things, correct? So, looking back at your original variables, you've got 2 and 3. One with the least is 2. My answer needs 2. Okay. So, 1, 2, you see this reads 7,659. 1, 2, the 5 bumps the 6 up. So 7, 7, and you have to put those placeholders in there, okay? Because 7,700, it has to be similar to the number you have. They have to have those placeholders. All right, and since it was math, you go get your unit from here, it's grams. Put the unit there, and you put your grams there. You do need your units. Okay? All right, last one. This one you're missing volume. I'm gonna take my variables, plug them in. Got that part down right now, so far. 3 is my density, okay? Mass is 378. And I don't know my volume this time, so I'm just gonna write a B. I don't know what it is. This time when you use the butterfly method, you have to do an extra step. Because when you bring your B up and across, okay, I'm gonna put this over 1, you can, all right? You're gonna have to do an extra step, because when you bring your B up and across, you're gonna have 63 V, okay? That's me bringing this up and across. Equals, there's my equal sign, okay? The 1 up and across, which just leaves this 378. All right? So that was doing the butterfly method, bringing this one across, and bringing this one across, this over this side. Okay? So I have one extra step because B is still not alone, and they have to be alone on the equal sign. So when you do the opposite, they're being multiplied and divided, right? So they're being multiplied, I'm going to divide, 63. Divide, 63. Okay? And then I'm left with B equals, here's my math, all right? So that in your calculator. 378 divided by 63, okay, to 6. But I need, now this, pay attention, because you need 2 sig figs though, okay? So I'm gonna write 6, all right? But it's exactly 6, so you're gonna need 6.0, because you need 2 sig figs. So go ahead and put 0.0 if you need 2. And for units, back over here, milliliters. So they're using in the density with milliliters per volume, so that would be your unit, okay, because you were solving for volume. So you need to have the volume units there.